So this will be our third video to finish out the Unit 10 notes packet. And we're going to do a little bit of math and just kind of introduce how you would start out balancing chemical reactions. So we have two examples that are going to work here. And this will be the two ways that we demonstrate the law of conservation of matter. So for this first example, we have SN, which is the element 10. And we have HF, which is hydrogen and fluorine that makes hydrofluoric acid. And then we have an arrow indicating that a chemical reaction has taken place. And we have, you can see where the hydrofluoric acid has split. And the 10 is now with the fluorine, making 10 fluoride. And hydrogen gas is now over here by itself, right here. So the first thing we've got is, let's go ahead and recognize that these are the reactants over here on this side. This is what combines together at the beginning of the chemical reaction. And then these are the products. This is what we make. So the first question is, how many atoms are on the reactants side of the chemical equation? So to do that, we need to basically kind of split our chemical equation down the middle at the arrow. You could almost think of this as like an equal sign, like in math. And we need to list out the elements that we have. We have 1, 2, 3. We have 10, we have hydrogen, and we have fluorine. You've got to kind of write small to get that to fit. And we have those same elements also over here on the product side if we wanted to list them out. And I like to do it in the same order as I did on the reactant side. So using a skill that we learned in Unit 9, how many 10s do we have on the reactant side? We have 1. There's an understood 1 here, and there's a coefficient of 1. How many hydrogens do we have? Remember, there's an understood 1 there, but there's a big coefficient of 2 that we multiply that 1 by. So we have 2 hydrogens. And then how many fluorines do we have? There's an understood 1 there, and we multiply by the coefficient of 2, so we get 2 fluorines. So to go back and answer the question, how many atoms are on the reactants side of the chemical equation? 1 plus 2 plus 2 gives me 5 atoms total. Then the next question, how many atoms are on the products side of the chemical equation? So I've already kind of got it set up, and I'm going to go ahead and count and see. I have an understood 1 here for 10, and there's no coefficient, so that's just 1 10. For hydrogen, I have 2 as my subscript, and there's well, you can say there's an understood 1 for the coefficient, but there's nothing there written. So there's 2 for hydrogen. And then for fluorine, there's a 2 for the subscript and nothing for the coefficient. So there's 2 fluorines. So I've got 1 10 plus 2 hydrogens plus 2 fluorines equals 5 atoms total. So I have the same number of atoms on the reactant side as I do on the product side. So my next question says, what do these numbers tell you? This tells me that this chemical reaction follows, and in chemistry you can abbreviate the word reaction for RXN. This reaction follows what's that law we're learning about in this unit? Follows the law of conservation of matter. It states that matter cannot be created, it cannot be destroyed, it can only change forms. If 1 10 and 2 hydrogens and 2 fluorines go in the reaction, then 1 10, 2 hydrogens, and 2 fluorines must come out of the reaction. We can't just magically have gold appear on the product side if gold didn't go in the reaction to begin with. You may have heard of like alchemists in medieval times trying to figure out how to make gold for their king, and you just can't do that. It doesn't work that way. Now, this is another way that the law of conservation of matter could be demonstrated, and it has to do with masses of products and reactants. And this really comes into play with your math skills, and you get to use a calculator. So we have 15 grams of tin. This is the same reaction as above, plus I don't know how much hydrofluoric acid. So in math, when we don't know how much, instead of doing a question mark, in math, we use the variable x. And then instead of the arrow, we draw an equal sign. 37 grams of tin fluoride was made, plus 16 grams of hydrogen gas. A lot of bubbles were made, that hydrogen gas. Remember, it's very flammable. So in math, to solve this, you've got 15 plus x equals 37 plus 16. How would we start by solving that equation? We would combine like terms, right? So on our calculator, or if you're good enough, you can do that in your head. I need to get a calculator that works. Give me 1 second. Okay, so on my calculator, I'm going to take 37 plus 16, and that gives me 53. So bring down this. 15 grams plus x equals 53 grams. Now, how am I going to get x by itself? I think the math teacher would say isolate the variable. I'm going to subtract 15 grams from both sides. So 53 minus 15 grams is going to equal x equals 38 grams. Okay? Now, you can go back and you can check your work. So you can go back and check your work by taking this 38, plug it in for x, and just real quick on your calculator, 38 plus 15 should give you the number you got over here, which is 53. So again, if 53 grams of reactants goes in the equation, then 53 grams of product should come out of the equation. We can't create matter, we can't destroy matter, we just change its form. If a 20-pound turkey goes in the oven, then a 20-pound turkey should come out of the oven. If 12 chocolate chip cookies go in the oven, 12 chocolate chip cookies better come out of the oven. So what I would like for you to do right now is I'm going to work through these problems, and I want you to work through them with me. I hope at this point you're a mature enough student that you've learned that just simply copying and not actually thinking about this is not really going to help you in the long run. So pause the video, work with me, do what helps you learn best. So for this reaction, it says our directions based on the law of conservation of matter, how many grams of HF were in the chemical reaction? Well, we just did that. That's 38 grams. That's what we solved. So for these practice problems, how many atoms of each element are present in the reaction below? So we're going to draw our line to divide it. And then we got to find the number of hydrogen atoms, chlorine atoms, potassium atoms, and oxygen atoms. So we're going to count them on the reactant side and the product side. And you got to be careful because things like hydrogen and oxygen will show up on in multiple compounds. Like hydrogen is here and hydrogen is here. So you got to be careful of that. So we've got an understood one here for hydrogen and an understood one here for hydrogen. So we have 1 plus 1 gives me 2 hydrogens for the reactant side. How many chlorines? Understood 1 gives me just that 1 chlorine. How many potassiums? There's understood 1s all over the place right here. So just 1 for that potassium. And oxygen, understood 1, just that 1 for the oxygen. Now I'm going to do the same thing in the same order on this side. How many hydrogens do I have over here? I've got that subscript of 2, and there's no hydrogens here, so 2. Chlorine has an understood 1, so there's 1 chlorine there. And potassium has the understood 1, so there's 1 potassium there. And oxygen has the understood 1 here, so there's 1 oxygen there. So we see that this chemical reaction between hydrochloric acid and potassium hydroxide making water and potassium chloride, it follows the law of conservation of matter Whatever goes in the reaction, that's what comes out of the reaction. 2, 1, 1, and 1 on both sides. So I'd like for you to try this one on your own. You know you're going to have practice problems where you have to do this on your own. So it'd be a good idea to go ahead and try it. All right, so for this one, we have, lots of hydrogens. We've got 2 hydrogens here, but also remember 2 times that understood 1 gives me 2 hydrogens there. So 2 hydrogens and 2 hydrogens make 4. 2 there and 2 there. Fluorine, 2 times that understood 1 gives me 2 fluorines. Calcium, this little 2 does not apply to that calcium, so there's just 1. And then oxygen, this little 2 does apply to that oxygen, so there are 2 oxygens there. Now let's check this side. How many hydrogens do we have? 2 times 2 gives me 4 hydrogens here. I'm looking to see if there's any more over there, and there's not. There's 2 fluorines here. Just that understood 1 for the calcium, and 2 times that understood 1 right there gives me 2 oxygens. When I kind of lean back and look at this, does it work out? Is the law of conservation of matter followed? It sure is. All right, then this next one, we're going to switch up gears because you're going to do both of these. This is like the first example at the top. This is like the second example at the top. We're going to be solving for x, just easy stuff in math. 20 grams plus x equals 27 plus 8. So please pause the video and solve this yourself, and then resume the video to check your work. So I'm going to use my calculator, and I'm going to combine like terms. 27 plus 8 is 35 grams, so 20 plus x equals 35. I'm going to subtract 20 from both sides, and x equals 35 minus 20, which is 15 grams. I'm going to go back and check my work by plugging 15 in. Does 20 plus 15 equal 35? I think it does. Might take a highlighter and highlight that. I don't like all these lines that get thrown across the page. I want that to stand out. All right, let's check this one. What is the missing mass in the equation below? A lot of times students want this to be harder than it actually is. It should be a real easy one for us once we know what to do. So 65 grams of hydrogen plus 27 grams of oxygen is going to make how much water? Remember, this arrow acts like an equal sign. So it's literally 65 plus 27 equals what? That's going to be our x. So 65 plus 27 is 92 grams. If I take 65 grams of hydrogen and 27 grams of oxygen and combine them together, I better make 92 grams of water. Highlight that answer. All right, what is the missing mass in the equation here? 17 grams of hydrogen plus, I don't know how much chlorine, equals 52 grams of hydrochloric acid. So I'm going to subtract 17 from both sides, and x equals 52 minus 17, which is 35 grams. Go back and check your work. Always check your work. So 35 plus 17, and that gives me 52. Now for this last one, does this follow the law of conservation of matter? Do this on both sides. Okay, so when I count the carbons, I get 2, the hydrogens, I get 6, and the oxygens, I get 2 on this side. But on this side, when I count the carbons, I get 2, which is working out good. The hydrogens, I get 6, and then the oxygens, I get 4 here and 3 here, which give me 7.